At 7:30 a.m. in Starbase, Texas, the countdown hit zero, marking the start of Flight 7's launch. The massive Starship stood tall against the morning sky, poised for its daring ascent. Engines ignited with a deafening roar, and the world's most powerful rocket began its climb towards space. For 2 mesmerizing minutes, the mission seemed flawless. The rocket pierced through the sound barrier, defying the thick atmosphere as engineers at Mission Control scrutinized every data point, tracking its progress with precision. Then, without warning, disaster struck. A blinding flash lit up the sky as the Starship's upper stage exploded, scattering debris across a nearby island. News outlets raced to report the event, while social media erupted with wild theories about the cause. Many pointed to footage that appeared to show the spacecraft's outer shell peeling away during ascent. "This must be it," they insisted. "This explains the explosion." But they were wrong, completely wrong. Today, SpaceX has unveiled the results of its official investigation, revealing a far more complex and captivating story than anyone had imagined. Welcome to Elon Musk 24 Hours, your go-to source for all things SpaceX and Tesla. Let's break it all down. Breaking investigation: SpaceX engineers uncover hidden truth behind explosion. After the dramatic failure of Flight 7, SpaceX engineers worked relentlessly, combing through countless data points, video footage, and debris fragments. What they uncovered shattered initial assumptions and revealed a far more complex truth about that fateful launch. The first major clue emerged from onboard footage captured 2 minutes into the flight. A dark ripple appeared to sweep across Starship's surface, igniting a storm of online theories. Some claimed it signified a heat shield failure, others warned of structural integrity breaches. These dramatic assumptions spread like wildfire across social media. But the real story was far different. The ripple wasn't a catastrophic flaw, it was a result of Starship's advanced design. SpaceX had implemented a groundbreaking flexible steel panel system on the spacecraft's exterior, built to adapt under extreme aerodynamic forces. "Think of it like dragon scales," one engineer described. "Tough but dynamic, offering protection while flexing under stress." Close to the ripple, a small, intentional opening had been temporarily sealed with a protective cover. This was no design flaw but a forward-thinking feature meant to accommodate future upgrades, including the installation of the chopstick catch system. As the rocket encountered maximum aerodynamic pressure, the cover flexed as designed and eventually detached. Despite speculation, this event had zero impact on the mission's tragic conclusion. The true culprit, however, was lurking much deeper, within Starship's powerful engine bay, where a hidden issue was about to be revealed. Critical failure uncovered, the oxygen valve malfunction that changed everything. As Flight 7 ascended into the thinning atmosphere, an unseen issue began to unfold, one that would ultimately spell disaster. A critical high-pressure valve within the oxygen supply system developed a malfunction. Initially, it seemed minor, a small leak releasing liquid oxygen into areas it was never meant to reach. But in the unforgiving world of rocketry, even a minor deviation can quickly escalate into catastrophe. With every passing second, the leak worsened. Supercooled liquid oxygen, kept hundreds of degrees below zero, accumulated dangerously in the engine bay. There, it came into contact with the immense heat generated by the Raptor engines, a recipe for disaster. The flight's data logs revealed the grim progression. Temperature sensors recorded sudden, erratic spikes, while pressure readings soared beyond safe thresholds. The onboard computer detected the anomaly, but by then it was too late. The accumulated oxygen, stressed by heat and mechanical pressure, ignited, triggering a spectacular explosion that brought Flight 7 to an abrupt end. SpaceX's investigation confirmed that the valve failure wasn't a random mishap, but the result of a known design limitation. Engineers had already been working on improvements, but the failure highlighted the urgency of these enhancements. Rather than dwell on the setback, SpaceX forged ahead. With lessons learned, work on Flight 8, designated S-34, was already underway, marking the next step toward a stronger, more resilient Starship program. S-34 Revolution, inside Starship's next-generation engineering breakthroughs. The S-34 prototype represents a significant leap forward in the evolution of SpaceX's Starship program, setting new standards for reliability and safety. Born from the lessons of Flight 7, this next-generation spacecraft is the product of meticulous engineering and bold innovation. Cryogenic testing triumph. At SpaceX's Maya Bay 2 facility, engineers subjected the S-34 to extreme cryogenic testing by filling its tanks with liquid nitrogen to mimic the harsh conditions of spaceflight. Not only did the tanks withstand these brutal conditions, but they also performed exceptionally, proving the durability and resilience of the new design. Revolutionized engine system. Following the valve failure that led to Flight 7's explosion, SpaceX engineers completely redesigned the oxygen supply system. The new high-pressure valves now feature redundant safety mechanisms and advanced materials capable of enduring extreme temperature shifts. Each Raptor engine underwent rigorous static fire testing at McGregor, with engineers carefully optimizing the critical oxygen-to-methane fuel ratio to ensure maximum efficiency and performance. Reinforced heat shield and aerodynamic enhancements. The heat shield on S-34 has been upgraded with reinforced tiles designed to withstand even higher temperatures during atmospheric re-entry. The aft flaps, vital for guiding Starship's descent, were strengthened to endure greater aerodynamic forces, enhancing flight stability. Refined flexible panel system. The innovative external panels that sparked speculation during Flight 7 have been refined to strike the perfect balance between flexibility and security, maintaining their adaptive properties while ensuring structural integrity throughout the flight. Flight 8 mission goals. Flight 8 will build upon previous successes while aiming for new milestones. The Super Heavy booster will once again carry Starship to the edge of space, with upgraded monitoring systems tracking every aspect of the separation sequence. In a groundbreaking attempt, the booster will conduct a controlled descent and utilize the newly installed chopstick catch system, an audacious maneuver that could redefine rocket reusability and cement SpaceX's role as a leader in aerospace innovation. The S-34 prototype is not just an evolution, it's a statement of SpaceX's relentless pursuit of progress and its commitment to making humanity's interplanetary ambitions a reality. Mission evolution. Flight 8's groundbreaking orbital test plans unveiled. Flight 8 is poised to be SpaceX's most ambitious mission yet, with plans for the first true orbital test flight of the Starship system, pending regulatory approval. This mission is more than a routine test. It's a pivotal demonstration of SpaceX's relentless pursuit of innovation and progress. Heat shield's ultimate trial. The reinforced heat shield, a critical component of the upgraded Starship design, will face its most formidable challenge yet. During re-entry, the spacecraft will hurtle back through Earth's atmosphere at speeds exceeding Mach 25. This trial by fire will test the shield's ability to protect Starship from intense heat and extreme aerodynamic forces. Learning from Flight 7. The oxygen valve failure that brought Flight 7 to a dramatic end has become a lesson in resilience and improvement. Engineers implemented a fully redesigned valve system featuring enhanced materials and redundant safety features. What began as a setback has driven meaningful advancements, ensuring safer and more reliable future launches. Shaping the future of space travel. Scheduled for early 2025, Flight 8 has captured the attention of the aerospace industry. Enhanced monitoring systems will meticulously track every stage of flight, from liftoff to booster separation and re-entry. If successful, this mission will be a historic step toward making Starship a fully reusable spacecraft capable of supporting missions to the Moon, Mars, and beyond. SpaceX's innovation philosophy. Flight 8 is a testament to SpaceX's philosophy. Setbacks are not failures but opportunities to grow and innovate. The company's journey underscores that progress is often nonlinear, requiring bold attempts, thoughtful analysis, and relentless determination. As Flight 8 prepares for launch, one thing is clear: each challenge has made SpaceX stronger, more inventive, and more focused on its ultimate goal, making humanity a true spacefaring civilization. The next chapter of Starship's story is about to begin, with the promise of revolutionizing our future in space. Engineering triumph. How Flight 7's oxygen leak led to revolutionary safety systems. SpaceX's Flight 7, though ending in tragedy, directly catalyzed groundbreaking improvements in valve design and safety systems. What initially seemed like a setback has, in fact, propelled the company forward. The lessons from this event have been transformative, and today, we take you behind the scenes to understand how the oxygen leak led to the development of cutting-edge technology that will ensure the safety and success of future missions. Stay ahead of every new breakthrough in space exploration by joining our community of enthusiasts at Elon Musk 24 Hours. Hit the subscribe button, ring the notification bell, and share your thoughts on these critical safety innovations in the comments below. Let's continue this journey of discovery and innovation together. A historic moment in spaceflight. It was a clear morning at Starbase in Boca Chica, Texas. As 33 Raptor engines ignited, Starship Flight 7 began its historic mission. The ground trembled as the rocket's massive thrust powered it towards space. For a moment, humanity watched as Starship fought against gravity's grip, demonstrating the incredible advancements in rocket technology. Yet, just minutes later, the skies over the Gulf of Mexico would bear witness to both the triumph and the tragedy of space exploration. Spaceflight has always been a tremendous engineering challenge, especially when it comes to the rocket engines. These engines often account for over 70% of a rocket's cost and are the result of decades of research and design. For Flight 7, these engines were the heart of the mission's success and eventual failure. The innovations embedded in each Raptor engine demonstrated just how far we've come in the pursuit of interplanetary travel. Flight 7's unprecedented staging attempt. At T+3 minutes and 45 seconds, Starship attempted a maneuver never seen before in spaceflight, a hot staging separation at hypersonic speeds. This maneuver required the upper stage's engines to ignite while still attached to the booster. Many experts had deemed this impossible, but when the engines roared to life, mission control erupted in celebration. For a moment, SpaceX had achieved the unthinkable. But the mission was far from over, and space exploration is unforgiving. Just after T+4 minutes, the first warning signs appeared on the control screens. A fuel leak had been detected above the methane tank, which quickly escalated into a crisis. The oxygen leak crisis. As telemetry began to show increasing pressure in the flap hinge area, engineers scrambled to assess the situation. The leak worsened, and soon a fire erupted, fueled by escaping methane. The flames spread rapidly, threatening the structural integrity of the spacecraft. As the situation deteriorated, Mission Control made the difficult decision to activate the flight termination system. The sky over the Caribbean was illuminated as Starship disintegrated, its debris scattering across the horizon. In those final moments, engineers had done all they could to contain the issue, but the leak had proved too catastrophic. Yet, even in failure, the mission provided valuable data that would shape the future of spaceflight. The Raptor engine, a revolution in aerospace. Despite the tragedy of Flight 7, the Raptor engines had achieved something extraordinary. Each Raptor 2 engine generates up to 230 tons of thrust, more than the entire Apollo lunar module that landed astronauts on the moon. The Raptor engine utilizes a full-flow stage combustion cycle, an innovation that was once thought impossible. When SpaceX first announced the development of the Raptor, many in the aerospace industry were skeptical. But the company's engineers defied expectations, achieving what the Soviets and Americans before them had failed to do. The full-flow stage combustion cycle is one of the most efficient rocket engine designs ever created, and its success is a testament to SpaceX's unwavering commitment to the future of space exploration. Transforming setbacks into progress. The oxygen leak that ended Flight 7's mission has already led to significant improvements in SpaceX's safety protocols and systems. Engineers have redesigned the valve system, incorporating enhanced materials and redundant safety features to prevent a similar issue in future launches. What initially appeared as a failure has evolved into a powerful learning opportunity, one that will make future spacecraft more reliable and resilient. Flight 7's tragedy, combined with the success of the Raptor engine, underscores an important lesson in innovation. Setbacks are not roadblocks but opportunities to push the boundaries of what's possible. As SpaceX continues its mission to revolutionize space travel, the lessons learned from every test flight, success or failure, will propel humanity closer to becoming a spacefaring civilization. SpaceX's relentless pursuit of perfection ensures that each challenge they face is met with new solutions and groundbreaking advancements. The journey to Mars and beyond is one step closer with each mission, and Flight 7's legacy will be felt for years to come.